Hello children, we are continuing with the same lecture here. So till now we have studied that necessary centripetal force while driving on a horizontal curved road is provided by frictional force. But however, frictional force has an upper limit. Beyond certain limit, we cannot increase the speed or the frictional force. It will causes damage to our tires and also there are chances of slipping. Also, the frictional force doesn't has any constant value as the roads are not uniform. So, we cannot only depend on the frictional force for safe driving on curved road. So the remedy for this or to avoid this, the surface of the road is tilted with the horizontal with some angle theta. This is called banking of road and the angle is called angle of banking. So many times while driving on the road, whenever there are turns or sharp turns, you might have observed the edges of the roads are raised above and make some angle with the horizontal. Okay, especially घाटातून ड्राइव करताना तुम्ही बघितलं असेल की थोडासा रोड जिथे शार्प टर्न आहे तिथे काय झालेला असतो, आतल्या साइडने टिल्ट झालेला असतो, उतार असतो एका साइडने आणि एका साइडने जे एजेस आहेत त्या काय झालेल्या असतात, उंच केलेल्या असतात. इट मेक्स सम अँगल. ओके, सो दिस इज नोन ॲज अँगल ऑफ, this angle is known as angle of banking and the process is known as banking of road. So today we are going to study the vehicle on the banked road, the motion of the vehicle on banked road. So consider the diagram given here. Consider a vehicle on a horizontal curved, but the road is now banked and it makes angle theta with the horizontal. So we can consider here the diagram given. So in this case, which are the forces acting on this vehicle? See, here we are going to ignore the air resistance. We are going to ignore the friction also. Okay. So now you can see the weight mg acting vertically downward. Here are the two forces only. One is acting its weight vertically downward, that is mg, and the second is the normal reaction n. Normal reaction n, which is perpendicular to the horizontal. If you will extend this n, you can see here it's a perpendicular with the horizontal road. So these are the two forces acting on this vehicle. Okay, so mg and normal reaction n. Now see, the necessary as the vehicle is taking a turn, means horizontal curved turn. So here the centripetal force must be act, means the resultant force must be towards the center of the track. Okay, so centripetal force must be towards the center of the track, means resultant should be a centripetal, means the acting vertical forces, that is mg, must be 0, means mg should becomes 0. So for that we should consider as mg should become 0, means there must be the components which balances mg. So let us resolve this normal reaction n into two components. One which is vertical component n cos theta and horizontal component n sin theta. Now here the n sin theta is horizontal while n cos theta is vertical. This n cos theta vertical component balances mg. It balances mg, and therefore the vector sum of mg and n cos theta becomes 0. Now the only resultant force acting is n sin theta, and which is towards the center. Now the centripetal resultant force is n sin theta, so that it can perform a circular curved motion. Okay, it helps to trace the curve, and this also balances centrifugal force. So we can write here the two equations. See how we can write the two equations from this to the information. First one, that is n cos theta is equal to mg, which balances the weight. N sin theta is equal to centripetal force, and this also balances centrifugal force. That's why we can write n sin theta is equal to mr omega square, which is equal to also mv square upon r. Let's call this as equation number 2. Now let us take the ratio of the two. So we'll get n sin theta upon n cos theta is equal to mv square upon r upon mg. And get cancelled, and sin theta upon cos theta is equal to tan theta is equal to mv square upon r into reciprocal of mg. Here also mm get cancelled, and here remains v square upon rg. So we'll get the equation tan theta is equal to v square upon rg. Let us call this equation as equation number 3. Now rearrange this, and we'll get v square is equal to rg tan theta. Taking square root on both the sides, we'll get v is equal to under root rg tan theta. So this is a safe speed. It's not a maximum speed also, and this is not a minimum speed also. This is a safe speed with which any vehicle can be safely driven on the banked road of radius r and angle theta. So this expression Vs, let's call this speed as Vs, which is a safe speed. So Vs is equal to under root rg tan theta. This is the most safe speed of the vehicle on the bank road of radius r and banked angle theta. R and theta may be vary. Now see, this expression also gives us a banking angle or angle of banking with which we can design a road. See, our equation number 3, here it is given tan theta is equal to v square upon rg. So tan is therefore the theta is equal to, you can take tan inverse of v square upon rg. This is the value of theta you can find out to design a road, banked road. Okay, so with these two expressions we can find out angle of banking and safe speed on banked road. Okay, so the remaining part of this expression is what will be the maximum speed on the bank road and what will be the minimum speed on the bank road to drive. So that we'll see in the next lecture. Okay, if you have any doubt related to this, you can ask me anytime. Okay, bye.